Hello, this is Irfan from Javelin Technologies. Today we'll be looking at the use of symmetry if we have a model which is made up of shell elements. Let us look at the full length model first. What we have is a model which has been constrained on the two sides. It looks like an L-shaped body. A pressure has been applied to the two faces and a force has been applied across that edge. When the analysis is run, that's how the displacement looks like. We can see that the model is symmetric, so we can cut it across the center plane and use that model. A configuration has been created to do that, and that is now half the model. We look at the constraint. We have already constrained those two edges, and we have to apply symmetry at that edge. If symmetry has to be applied, we can use a standard symmetry fixture, but when we try to do that, the only thing that we can select are faces. But this symmetry is across an edge. There is no face because this is a shell element, so we cannot select any face for the purpose of symmetry. So our next option is we can try using a reference geometry. So we'll use the reference plane and we'll constrain any displacements which on that plane which are normal to the plane. So that will allow the faces to slide along that plane, but it will not allow it to penetrate the plane of symmetry or pull away from that. So that's pretty much how symmetry condition works in Solid. So let us see if that's going to work. Once we run the analysis, the results look drastically different. So the symmetry condition has not been applied properly, although the things have not entered into that plane of symmetry, but we have some displacement discontinuities if you take the first derivative, or there are some rotations along that plane which are not continuous. So the way we would impose the complete symmetry condition is by then going back to the reference geometry and by constraining any displacement normal to the plane, and at the same time all the rotations on the which are along direction 1 and direction 2 of the plane. Any normal any rotations along the plane or normal to the plane are then left free. Just a quick tip over here: if you were to select one direction for constraining the symmetry, you should select the opposite two rotations to impose the symmetry boundary condition. Anyhow, let us look at how the results will look now. So if you look at the maximum displacement here, it is the same as the displacement that was achieved when we ran the full length model. So the appropriate symmetry condition has been applied, so we have to constrain one displacement which is normal to the plane and also the rotations in direction 1 and direction 2 along the plane of symmetry. So that is how symmetry condition can be fully imposed.